Hello my dear students. So now I am going to discuss some extra questions with you all. This is related to the lesson changes of matter. So under changes of matter, you all can remember we discussed what physical and chemical changes are. Then under chemical changes or chemical reactions, we discussed the 4 types of reactions. You all can remember them: chemical combination, chemical decomposition, then the single displacement and double displacement. Thereafter, we discussed how metals react with air, that is oxygen in air, water, different types of water, that is cold water, hot water, steam, and then how they react with acids. Thereafter, we discussed how metals can displace another metal from a salt solution. And from there, we were able to understand how the activity series of metals were arranged and the uses of activity series. And after that, we discussed how we can extract iron from its ore, that is hematite, using the blast furnace. And also metals like gold, which are inert metals or native metals, they don't need a strong separation technique, but they need a physical separation technique to separate them from their impurities, because they exist as metals in nature. And after that, we discussed 3 types of gases: hydrogen, oxygen and carbon dioxide. We discussed their physical properties, chemical properties. We understood how we can collect them in the lab and also how we can identify them in the lab to confirm that it is a certain gas. And also we discussed the uses of all these gases. So in that lesson, I have already discussed the questions given in your textbook. So these are some extra questions. I am sure students, as I put the slide, you will answer the question first and then you will listen to my discussion to correct your answers. So we'll start with the first question, extra question 1. The first one, physical change given below. So you all know students what physical changes and chemical changes are. In a physical change, there is a rearrangement of constituent particles so that the substance changes from one state to another state. Solid, liquid, gas, or back to gas, liquid and solid, or solid to gas, gas to solid. So those are the physical changes. In a chemical change, you have the initial chemical substances, the reactants, and they are converted to new substances which are the products. So there is a conversion of reactants to products taking place. So physical change, evolving of carbon dioxide when limestone is heated. So you all know students, limestone is what? It is calcium carbonate. So when we heat calcium carbonate, what happens? There is a chemical decomposition reaction taking place and there calcium oxide and carbon dioxide are formed. So that is a chemical reaction. Rusting of iron. When iron rusts, there is oxygen and water along with iron. They get converted to rust. So there again, you have the reactants, you have the products. We have not discussed the process in detail, but I have mentioned this before. So from the reactants, you get the products. So that is a chemical reaction. Then melting of wax on heating. Wax is a solid substance. When you say melting, the solid becomes a liquid. So solid wax becomes liquid wax on heating. That is melting. That is a physical change. The last one, burning a strip of magnesium in air. So magnesium is a metal. When you burn it in air, it reacts with oxygen in air and forms magnesium oxide. It is a chemical combination reaction. So that is a chemical reaction. Physical change given below is melting of wax on heating. Then the second question, chemical combination reaction given below. So you're familiar with the 4 types of reaction, students. Chemical combination, there are more than one reactants, they become one product. In a chemical decomposition reaction, there is one reactant that gets decomposed into more than one substances, 2 or more substances. If it is single displacement, one element, one compound, and the element displaces another element from the compound. In a double displacement, there are two compounds and both the compounds get displaced. Both parts of the compounds get displaced by the other two parts of the other compound. That's why we call it double displacement. So, if we look at these reactions, you can identify the types. First one, 2 magnesium plus O2 giving rise to 2 MgO. So, two reactants, magnesium and oxygen, giving rise to magnesium oxide. So, that is combination. If you take the next one, calcium carbonate giving rise to calcium oxide and carbon dioxide. That you all know, when we supply heat, calcium carbonate decomposes. So, that is decomposition. How about the third one? Potassium permanganate becoming potassium manganate, manganese dioxide and oxygen. The reaction that we use to collect oxygen gas, that is also decomposition. When we heat potassium permanganate, you get oxygen gas. So, that is also decomposition. What is this one? Copper sulphate, zinc, giving rise to zinc sulphate and copper. What happens here? Zinc displaces copper from the salt solution. So, that is a single displacement reaction. So, this is single displacement reaction. So, now you all know the 4 types, students. 4 reactions. First one combination, the other 2 decomposition, last one single displacement. So, we need to identify the chemical combination given below. So, this is the chemical combination reaction. Is that clear, students? So, then we will move on to the next slide. Third question, a metal that exists as a native metal in the environment. What is the meaning of native metal? Metals that are less reactive or have low reactivity. Because of that, they exist as metals in nature. If you take the activity series, we start with potassium, sodium, calcium, magnesium, very high reactivity. And in the middle, you have zinc, iron, tin, lead, copper. Those are moderate reactive elements or metals. Whereas the metals at the bottom of the activity series, silver, platinum, gold. These metals have very low reactivity and therefore they exist as metals in nature. We call them as native metals. They don't exist as compounds. So, native metal. Iron, as I told you, moderate reactivity. Sodium, high reactivity. Gold, the last element in the activity series that has the lowest reactivity. Calcium, the third element in the activity series. So, that is also highly reactive. So, gold is the element or metal that exists as native metal in the environment. Gold. Au, gold. Then we have the fourth one. A chemical reaction that cannot be used to collect oxygen gas in the laboratory. So, a chemical reaction that cannot be used to collect oxygen gas in the laboratory. Now, students, for you all to recall all the chemical reactions, I will write down the equations as well. So, while answering the question, you will again recall writing and balancing reactions as well. Heating calcium carbonate. Calcium carbonate, when you heat, what do you get? You get calcium oxide and carbon dioxide. How about heating potassium permanganate? KMnO4. When you heat that, you get K2MnO4, MnO2 and O2 gas. So, you have to check whether it is balanced. It is not. We need to have a 2 there. So 2KMnO4 giving rise to K2MnO4, MnO2 and oxygen. How about decomposition of hydrogen peroxide? Hydrogen peroxide, H2O2 gives rise to H2O and O2. So here again we need to have 2 H2O2 and 2 H2O gives rise to 1 oxygen. So these are all decomposition reactions. Then heating potassium nitrate. That is also something that you know. Potassium nitrate, KNO3, when you heat, you get all these heating or decomposition. Here KNO3 gives rise to KNO2. Potassium nitrate, potassium nitride and oxygen gas is evolved. So here we need to have 2. So 2 KNO3 gives rise to 2 KNO2, potassium nitrite and oxygen. What was the question? A chemical reaction that cannot be used to collect oxygen gas. So you can use potassium permanganate, you can use hydrogen peroxide and you can use potassium nitrate. But you cannot use calcium carbonate. So that is the reaction that does not give oxygen. So heating calcium carbonate. Is that clear, student? So with that, I will move on to the next question. Question number 5. Gas used in the production of margarine. You all know the gas that is used in the production of margarine. Hydrogen. Hydrogen is a very light gas, so we can fill balloons. It is a combustible substance. It can be used as a fuel, rocket fuel. Then in the production of ammonia, urea, for all those we use hydrogen. If you take the first answer, carbon dioxide. Carbon dioxide, you all know we use it to make fire extinguishers because it is a non-supporter of combustion. Then it is used as dry ice. And also it is used to make rain, the artificial rain. So like that, carbon dioxide can be used. Then we have oxygen. Oxygen is needed for respiration, so oxygen cylinders. Then we use it for combustion, oxyacetylene gas. So for all those we use oxygen, even production of certain acids. So for that also we use O2 gas. Then N2, nitrogen. Nitrogen again is needed to produce ammonia gas. Nitrogen is used, it is also somewhat inert, so we use it to fill milk packets, food packets so that they can remain fresh and crispy. So nitrogen is used for that purpose. Then hydrogen, already I told you all, and the gas used in the production of margarine, that is hydrogen. Then the next one, question number 6. A reaction that does not take place in the blast furnace. So I am sure students you all can remember the reactions taking place in the blast furnace. Shall we quickly recall all those reactions? First we have the raw materials, hematite, that is the iron ore, then coke, carbon, and limestone, calcium carbonate. So what happens first? Carbon reacts with oxygen forming carbon dioxide. Carbon dioxide again reacts with carbon to form carbon monoxide. Carbon monoxide is the substance or reductant or reducing agent that reduces iron from the ore. So hematite reacts with carbon monoxide forming iron and carbon dioxide. Then we have calcium carbonate that decomposes to give calcium oxide and carbon dioxide. This calcium oxide reacts with silica and alumina. Silicon dioxide and aluminium oxide, those are the impurities present in iron ore. So then slag is formed. So those are the reactions that take place inside the blast furnace. So I am sure you all can remember all the equations relevant to these reactions. If we look at the answers. So a reaction that does not take place in the blast furnace. Calcium carbonate decomposing to form calcium oxide and carbon dioxide, it does take place. Then Fe2O3, that is hematite, carbon monoxide, that is the reductant, giving rise to iron and carbon dioxide, that also takes place. Then carbon reacting with oxygen forming carbon dioxide, yes, that also takes place. Then how about the last one? Iron reacting with oxygen to form iron oxide or ferrous oxide. This does not happen inside the blast furnace. So that is the reaction that is not taking place. So a reaction that does not take place in the blast furnace is the reaction of iron with oxygen to form iron oxide. Can you all understand that? So then we will move on to the next slide. Question number 7. False statement regarding the reaction of magnesium with water. So here students, you all have to remember magnesium with water. So when we say magnesium with water, you have to immediately recall. Now when you put magnesium to cool water, what happens? There is no reaction. Then if you put magnesium into hot water, what happens? You can remember it reacts to form magnesium hydroxide and it evolves hydrogen gas. And also you need to balance the reaction. So magnesium with water, that is hot water, gives rise to magnesium hydroxide and liberates hydrogen gas. Then if you put magnesium with water but steam, then what happens? It gives rise to magnesium oxide and liberates hydrogen gas. Is that clear, students? You all can remember all these reactions. Magnesium doesn't react with cool water, reacts with hot water to give magnesium hydroxide and hydrogen gas. Magnesium reacts with steam to give magnesium oxide and hydrogen gas. So let's look at the question and the answers. So here they want us to find the false statement regarding the reaction of magnesium with water. What is it? Magnesium doesn't react with hot water. That is incorrect. Magnesium does react with hot water. Second one, magnesium reacts fast with steam. That is correct. Now it doesn't react with cool water, it reacts with hot water. It can react fast with steam. And magnesium doesn't react with cool water. That is also correct. So these two are correct. Hydrogen gas is released when magnesium reacts with steam. That is also correct. We saw all the reactions. So out of these, the false statement is magnesium doesn't react with hot water. That is the false statement. Then the next one. Values of X, Y and Z respectively in the reaction given below. So here you can see, you can identify this reaction, students. Iron reacting with water. Actually, iron reacts with steam, if you can remember. It doesn't react with cool water. It does not react with hot water. Instead, it reacts with steam. So when it reacts with steam, iron oxide is formed, Fe3O4, and hydrogen gas is evolved. So we need to balance this equation. So if we do that, now Fe plus H2O gives rise to Fe3O4 evolving H2 gas. How do we balance this? Now here you can see Fe3. So you need to have a 3 here, but before that we need to balance the other substances. Now here see H2O, so there are 2 hydrogens, but oxygen there's only 1, there are 4 oxygen atoms. So what do we need to do? We need to put a 4 here. So oxygen becomes 4, but then hydrogen is 8. So you can balance that putting 4 there. So then of course no problem, iron 3, you need to have 3 there. So what are the values? 3 is X, then you have 4 Y, and Z is again 4. So 3, 4, 4 are the values. So values of X, Y and Z respectively are 3, 4 and 4. The last answer. I am sure you also did it correctly. I am sure you can remember this equation and you know to balance it correctly. Is that clear, students? So then we'll move on to the next one. So the question number 9. Select the true statement regarding the chemical reaction given below. So under that you can see, students, they have given the relative atomic masses for iron Fe56, carbon 12 and oxygen 16. So then you are familiar with this reaction also. What is it? Fe2O3, that is hematite, and 3CO, that is carbon monoxide, and that is where the iron O is reduced by carbon monoxide to form iron in the extraction of iron inside the blast furnace. So here you get 2 Fe and 3 CO2. If we look at the question, now we need to select the true statement regarding the chemical reaction. So here if you look at the answers, first one, 1 mole of CO is required to completely react with 1 mole of Fe2O3. Here students, you are familiar with this reaction. Now if we take the ratio, here you can see there is 1 Fe2O3. There are 3 CO, carbon monoxide molecules. To react, when they react together, 2 iron is formed and 3 CO2 are evolved. So you all know that is like the mole ratio. 1 mole of Fe2O3, 3 moles of carbon monoxide gives rise to 2 moles of Fe and releases 3 moles of carbon dioxide. That is how we get information from a balanced chemical equation. So you know that. So 1 mole of CO is required to completely react with 1 mole of Fe2O3. That is wrong. Why? This is 1 mole, this is 3 moles. So that's wrong. This is not correct. Not the true statement. Second one, 1 mole of CO2 will be produced when 1 mole of Fe2O3 is reduced completely. Is that correct? No. Why? Here you can see this is 1 mole, 3 moles of CO2 is released. So 1 mole of hematite will give rise to 3 moles of carbon dioxide. So this is also incorrect. Then it says 56 grams of Fe is extracted from 160 grams of Fe2O3. To do that, we need to have the relative molecular masses of these compounds. Now here the relative atomic masses are given. If we calculate for Fe2O3. Now there are 2 iron atoms. I will do it on this side. There are 2 iron atoms into 56 plus there are 3 oxygen atoms into 16. So here this is going to be 2 into 56, 112 plus 3 into 16, 48. So that is going to be 160 grams per mole if you write it as the molar mass. So there are 56 grams of Fe is extracted from 160 grams of Fe2O3. This is 160 grams. That is okay. But look at Fe. There are 2 moles of Fe being produced. So if you take 2 Fe, that will have to be 56 into 2. So there will be 112 grams of Fe produced. So from 160 grams, you will get 112 grams of Fe. So that is also incorrect. Then we have the last one. Look at the last answer. Here you can see 132 grams of CO2 will be produced from the complete reaction of 160 grams of Fe2O3. So we need to calculate for CO2 as well. CO2, carbon dioxide, carbon you all know is 12. Then there are 2 oxygen atoms into 16. So that is going to be 12 plus 32, 44. Like this, how many carbon dioxide are produced? There are 3 carbon dioxide produced. So for 3 moles of carbon dioxide, what do we need to do? We need to multiply 44 into 3. So that is going to be 3 by 4, 12. So 12, 132 grams. So obviously from 160 grams of Fe2O3, we will get 132 grams of CO2. So if we look at the answer, grams of CO2 will be produced from the complete reaction of 160 grams of Fe2O3. That is correct, no? So Fe2O3 we calculated it as 160 grams. Carbon dioxide 1 was 44. So there are 3 moles, that is equal to 132 grams. So that is the true statement. I am sure you all can understand that, students. So then the next question. Question number 10. Metal that does not react with air on heating. So you can remember, students, we had all the different metals of the activity series. Sodium you don't even have to heat. When you expose it to air, it reacts very fast. But magnesium, if it's normally exposed to air, it's a slow reaction. But when you burn it in air, it burns fast. Whereas if you take metals like zinc, iron, you will have to heat them for a very long period of time so that they will undergo a change. So is that clear? Now look at the question. Metal that does not react with air on heating. So magnesium, it reacts with air. It burns in air with a bright white flame. You have seen that in the lab also. Then zinc, on prolonged heating, it does react. The color tarnishes and then it forms zinc oxide. Sodium, you don't even have to heat it. It directly reacts with oxygen. Just when it is exposed to atmospheric air, it reacts immediately with oxygen. If you take silver, the metals at the bottom of the activity series, silver, platinum, gold, what do we call them? They are the native metals. Now these native metals usually are very, very less reactive. So silver does not react with air even on heating. Even if you heat it very strongly, it won't react. So the metal that does not react with air on heating is silver. Is that clear, student? So you will have to always remember the metals in the activity series, their order, descending order of reactivity and all the different types of reactions that we have discussed before. So with that, I will move on to the next question. Question number 11. Not an evidence for the occurrence of a chemical reaction. So it is not an evidence. So you all know, students, we observe a chemical reaction when we see changes occurring to the reactants or the reactants being consumed and the products being produced. So how do we identify them? There are so many different changes you are familiar with. Let's look at the answers. The first one, formation of precipitate. This is something familiar to you all. When we add a certain metal, now say even when we put zinc into copper sulphate. Now copper sulphate solution is blue in color. We have zinc, the metal, and you have the solution, blue color solution. When they react, what do you see? You see the dissolving of zinc. At the same time, you see the blue color of the solution decreasing and you see a brown color precipitate being formed. That is a brown color solid substance depositing. So that is one reaction. Then if you consider the reaction of sodium sulphate with calcium chloride, what happens there? Calcium sulphate precipitates. A white color precipitate is formed. So like that, you have seen reactions where precipitate is formed. So that is an evidence. Then liberation of gas. If you put magnesium into hydrochloric acid, for that matter, any metal that reacts with dilute hydrochloric acid or dilute sulphuric acid, magnesium, aluminium, all these metals, they react. Zinc, then they liberate hydrogen gas or evolve hydrogen gas. So that is an example. Even calcium carbonate with hydrochloric acid releases carbon dioxide gas. So these are evidences for occurrence of a chemical reaction. Then container becomes warm. Container becoming warmer, container becoming cooler. These are also evidences. For example, if sodium reacts with water, we take a large amount of water because there is a lot of heat evolved. There can be explosion. To avoid that only, we take a large container, a trough with water and use only a small piece of sodium. It's a violent reaction, evolves a lot of heat. When magnesium reacts with dilute acids, zinc reacts with dilute acids, there also heat is evolved. So the beaker container becomes warmer. That is also correct. Then the fourth one, solid turning into a liquid. Solid turning into a liquid, say wax, solid wax melting to form liquid wax, or solid ice becoming water, liquid. Those are changes, but they are not chemical changes. They are physical changes. Only the state changes from solid to liquid. So it is a physical change. So not an evidence for the occurrence of chemical reaction. It is the solid turning to a liquid. Question number 12. Consider the statements given below regarding the activity series. So when they say activity series, we will just try to recall the elements of the activity series. I am sure you all can remember that. What is the order? We start with potassium, then we have sodium, calcium, magnesium, aluminium, then we have zinc, then we have iron, tin, lead, then there is copper, mercury, then we have silver, platinum and gold. I am sure you can remember this order. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, copper, mercury, silver, platinum and gold. Have I left out something? What is that? That is hydrogen. We have hydrogen in the middle for the purpose of comparison. So after lead it is hydrogen. Then we have copper, mercury, silver, platinum and gold. So that is the order of the activity series. You have to remember that. So then using this, you can answer this question. This is to recall what you have learned because you have to remember the order of metals in the activity series. So here, consider the statements given below regarding the activity series. Reactivity of metals decreases from top to bottom of the series. That is correct. That is a correct statement. Why? When you look at the elements at the top, potassium, sodium, calcium, very reactive. Whereas at the bottom, silver, platinum, gold, the least reactive metals. So reactivity of metals decrease from top to bottom of the series. Then B, a metal that is above in the activity series can displace another metal below it from an aqueous solution. We have discussed this and seen these reactions. When you put zinc into copper sulphate, now you can remember the order. Zinc is above copper in the activity series. Zinc can displace copper from copper sulphate. But the other way, if you put copper into zinc sulphate, there will be no reaction. So a metal that is above in the activity series can displace another metal below it from an aqueous solution. That is also correct. If we write the reactions, you can remember, students, zinc plus copper sulphate gives rise to zinc sulphate and copper. Here copper is displaced. But if you put copper into zinc sulphate, then there will be no reaction. Because if you take the activity series, zinc is above, copper is below. So the metal that is above can displace a metal that is below in the activity series. You can remember that. So then, if we look at the answers, consider the statements given below, and from that you need to select whether they are correct or wrong. Only A is correct? No. Only B is correct? That is also no. Both A and B are correct. That is the correct answer, because you can see both the statements are correct. Both A and B are incorrect. That is also wrong. So that is the answer for this question. So I am sure, students, up to now you would have answered all the questions correctly, and you can recall what we learnt in the lesson before. So with that, we will move on to the next question. So this is question number 13. Substance that is not added as a raw material to the blast furnace. Look at the question carefully, students. So what does it say? Substance not added as a raw material to the blast furnace. So you all know what blast furnace is. What is that? That is the structure that is used to extract iron from its ore. So you all know that. And there are 3 different raw materials added to the blast furnace. Can you all recall those? One is the iron ore, hematite, Fe2O3. The other one is carbon in the form of coke, because it is needed to produce carbon monoxide, and also it evolves a large amount of heat when it reacts with oxygen. So that actually helps to increase the temperature of the blast furnace to a range between 1000 and 1900 degrees Celsius. Then we have limestone, calcium carbonate. Why do we need that? That reacts and forms calcium oxide, decomposes to form calcium oxide, which in turn reacts with aluminium oxide and silicon dioxide that are present as impurities in iron ore. So to remove them in the form of slag, we need limestone. So hematite, coke and limestone are the raw materials. So the question here, not added as a raw material. So that means it can be present in the blast furnace, but it is not a raw material. Look at the answers. Carbon dioxide. So like we discussed now, when calcium carbonate decomposes, carbon dioxide is produced. When carbon reacts with oxygen, carbon dioxide is produced. That again reacts with carbon to form carbon monoxide. That is the reductant that reduces iron from its ore. So there carbon dioxide is present, but it is not a raw material. But as you know, students, you all can see limestone is a raw material, coke is a raw material and hematite is a raw material. So the substance that is not added as a raw material is carbon dioxide. Then the next question. False statement regarding carbon dioxide gas. So you are familiar with carbon dioxide gas, CO2. Now they want you to select the false statement. So we will recall the properties of carbon dioxide. CO2, the relative molecular mass is 44. It is present in a small amount, 0.03% in atmospheric air, and also it is more denser than air. It is less denser than water. It is slightly soluble in water. It is a non-supporter of combustion, and also it is a colorless and odorless gas. So those are the chemical and physical properties of carbon dioxide. Let's look at the answers. Density is greater than air. That is correct, no? Density is greater than air. That is why we collect it using the upward displacement of air. So the second one can be collected by the upward displacement of air. That is also correct. Then it is a supporter of combustion. I told you all it is a non-supporter of combustion. That's why we have carbon dioxide fire extinguishers. So it is a non-supporter of combustion, and you can remember we test that in the lab. How do we do that? When we insert a burning splint, what happens? The fire is put off immediately. The flame is put off immediately because it is a non-supporter of combustion. So this is a false statement. Then dissolves slightly in water. That is also correct. So you know the false statement. What is it? It is a supporter of combustion. That's a false statement. So I am sure students, up to now you all were able to answer all these questions correctly. So with that, we'll move on to the next one. The next slide. We have question number 15 here. Consider the chemical reaction given below. So look at the chemical reaction. What is it? Zinc plus copper sulphate giving rise to zinc sulphate and copper. You all are familiar with this reaction. What is it? It is a single displacement reaction where the more reactive zinc displaces the less reactive copper from its salt solution, or the metal that is above in the activity series displaces the metal that is below it in the activity series from its salt solution. So that is the reaction. You are familiar with that. Select the false statement regarding the above reaction. So false statement. Blue color of the solution decreases gradually. Is that correct? Yes. Why? Copper sulphate is blue in color. So when copper is displaced, it deposits as a brown color substance. Zinc sulphate is not blue in color. So because of that, the color decreases. When copper is being displaced, copper sulphate decreases, so the blue color decreases gradually. Correct. Copper metal is more reactive than zinc metal. Now I told you all, you can remember the order, students. If you recall the activity series, you can remember we have zinc, then we have iron, after that we have tin, lead, hydrogen, and then we have copper. We have copper after that. So zinc is here, copper is here. Part of the activity series, zinc, iron, tin, lead, hydrogen and copper. So zinc is more reactive, copper is less reactive. So look at this answer. Copper metal is more reactive than zinc metal. It's incorrect. It is a double displacement reaction. Yes, we discussed that. And copper is present below zinc in the activity series. That is also correct. So what is the false statement? That is, copper metal is more reactive than zinc metal. Can you all understand that? Okay. So then question number 16. So look at question number 16. Products of the reaction of magnesium with steam is or are. So here magnesium and steam. Can you all recall the reaction? Magnesium with steam gives rise to magnesium oxide and evolves hydrogen gas. That is the balanced chemical equation for the reaction of magnesium with steam. So then, if we look at the answers, magnesium oxide only, they want you to write the products. Magnesium oxide only? No. Magnesium oxide and H2 only, that is correct. Magnesium hydroxide only? No. Magnesium hydroxide and hydrogen gas only, That is when magnesium reacts with hot water. This is when it reacts with hot water. You can remember that. Magnesium with hot water, magnesium hydroxide and hydrogen gas. So that is the answer. With that, we will move on to the next slide. Question number 17. Metal that cannot be utilized to prevent rusting of iron. Look at the question. Cannot be utilized to prevent rusting of iron. So again, if you recall, the elements that are above iron in the activity series, they are more reactive. Because of that, they can be used to protect iron from the rusting process. But the metals that are below iron, they are less reactive than iron. So, they are not that useful. So, always we choose a metal that is above iron in the activity series to protect iron from rusting. So, look at the elements. Again, if we take magnesium, zinc, aluminium, silver. So, again recall the activity series. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead. Then we have hydrogen, copper, mercury, silver, platinum and gold. Again the activity series. So you can see here magnesium, then we have zinc, we have iron, then we have aluminium here. All these are above iron in the activity series. So they can be used to protect iron from rusting. But if you take silver, that is below iron in the activity series. So that is less reactive. It cannot be used to protect iron from rusting. So the answer is silver. Is that clear, students? So then we will look at the next question, question number 18. Again, false statement regarding extraction of metal. False statement regarding extraction of metal. Again, if we use the activity series, now you can remember the highly reactive elements like potassium, sodium. What is the method used? We use electrolysis. Then for these metals like zinc, iron, tin, lead, what do? We use a reductant to reduce the metal from its compound. So here we use a reductant. When we say reductant, it can be an element or a compound that is used to reduce the metal. For example, iron is reduced by carbon monoxide. So like that, these elements can be separated. Then we have these three. Silver, platinum, gold. They exist as native metals. So these are native metals. Then what do? Now they only need to be separated from their impurities. They are present as metals. They have to be separated from impurities. So very simple physical separation techniques like sifting, that is used to separate the metal from impurities. So those are the information that you can get using the activity series in relation to extraction of metals. So now let's look at the question and the answers. False statement regarding extraction of metal. Sodium is extracted by electrolysis of fused sodium chloride. Yes, highly reactive elements are extracted by electrolysis. Iron is extracted by reducing a compound containing iron by a reducing agent. That is also correct. Moderately reactive metal. Zinc is extracted by electrolysis of the fused chloride of zinc. No, zinc is also moderately reactive. It is just above iron in the activity series. So this is incorrect. Gold is separated from its ore by physical methods. Yes, sifting is a physical method. So, the incorrect statement or false statement regarding extraction of metal is that zinc is extracted by electrolysis of the fused chloride of zinc. That is a false statement. Can you all understand that? So, with that students, we will move on to the next question. Consider the reactions shown below. So, you can see students, there are two test tubes. They have given you all the reactants as well. Now, look at the first one. Now, there they have marked the solution as copper sulphate and the metal or the substance, solid substance, you can see it is a metal. It is shown as A. And here, no solid deposits at the bottom. Blue color of the solution does not decrease with time. So, that means what? There is no reaction taking place. Here, again copper sulphate and B, and here you can see they have shown a brown color, a solid substance. So, that means there is something depositing. Brown color solid deposits at the bottom. Blue color of solution decreases with time. So, you can think of the reaction. Now, here there is no change. So, no reaction. There is no change, no reaction. Here you can say copper deposits. So, it has to be a single displacement reaction. You all can understand that. So, B has to be a metal that is above copper in the activity series. But A has to be a metal that is below copper in the activity series. So, if we have copper here, B will be somewhere up and A will be below copper. Is that clear? So, we will look at the question. Metals A and B can be. So, you can see here students, you can remember the activity series. We have been writing it again and again. So, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, platinum, gold. So, there if you look at A and B. Aluminium, silver. Aluminium is above iron, silver is below iron. So, it has to be the other way around. Silver, iron. Now, you can see iron is again above. Silver is below. So, silver below, iron above. That is correct. So, silver is somewhere below copper and iron is above copper. Magnesium and iron. Now, magnesium iron both are above copper. So, it cannot be A. Then magnesium and silver, magnesium is above, silver is below. So, that is also not correct. Can you all understand this, students? You have to recall the activity series. If we write all these elements, you can see aluminium is here. Before that, we have magnesium. Then we have copper, iron in the middle, then we have copper, then we have silver. So, only element that can be A has to be silver and the other one, it has to be one of these elements. So, silver and iron is correct. So, here we can label, underline this. Silver is below, A is below and B is above copper. So, iron is above copper. Is that clear? With that, I will move on to the next question. 20. An observation of the reaction between dilute sulphuric acid and sodium hydroxide. So, here dilute sulphuric acid and sodium hydroxide. If we write the reaction sulphuric acid H2SO4, sodium hydroxide NaOH, what are the products? We will get Na2SO4 and water. Na2SO4 and water. It is a double displacement reaction. You can see that. So the observations. Container becomes warmer. That is correct. Here heat is evolved during the reaction, so container becomes warmer. Formation of a precipitate. That does not happen. Sodium sulphate is not a precipitate. Occurrence of a color change. That also doesn't happen because all these solutions are colorless solutions. So that also doesn't happen. Liberation of a gas. Sodium sulphate is a salt, solid, dissolves in water. Water is a liquid. So there is no liberation of gas. So only thing that occurs, an observation of the reaction between dilute sulphuric acid and sodium hydroxide is that the container becomes warm. That is the correct answer. Then 21. The reaction mentioned above is a, what is that? It is a double displacement reaction. I told you all that. Chemical combination reaction? No. Chemical decomposition reaction? No. Single displacement reaction? No. It is a double displacement reaction. I showed you all the reaction. Sulphuric acid and sodium hydroxide, giving rise to sodium sulphate and water. So it is a double displacement reaction. If you want, I can show you all the reaction again. Here you can see hydrogen combines with OH, sulphate and sodium combine. So it is a double displacement reaction. So with that, students, we will move on to the next question. 22. Consider the physical properties of the gases given below. The first one, the density is higher than that of air. Density higher than that of air. What are they? Both oxygen and carbon dioxide have density higher than that of air. Only hydrogen has less than that of air. So this can be either O2 or CO2. Supporter of combustion. What is that? It is oxygen and it is combustible. Then what is that? Hydrogen is a fuel because it is combustible. H2 gas. So identify the gases P, Q and R. It can be oxygen, you cannot have hydrogen, and carbon dioxide, no. Carbon dioxide, hydrogen and oxygen. That is also not correct. Hydrogen, oxygen and carbon dioxide, not correct. Again, carbon dioxide, oxygen and hydrogen, that is of course correct. So it is the fourth one. Here you can see P carbon dioxide, Q oxygen and R hydrogen. Is that clear, students? So then I will move on to the next one. Question number 23. Answer that shows the correct balanced chemical equation for a chemical decomposition reaction. So you have to check two things. It has to be a decomposition reaction and it has to be balanced. So look at the answers. First one, potassium permanganate giving rise to potassium manganate, manganese dioxide and oxygen. That is a decomposition reaction. We have to check whether it is balanced or not. Now look at the values. 2KMnO4, 2K2MnO4. So there are 4 potassium atoms here. There is only 2 potassium atoms there. So there it is not balanced. So because of this, it is not balanced. Then the next one, zinc plus copper sulphate, zinc sulphate and copper. That is a single displacement reaction. So it is not a decomposition reaction. Then the next one, 2 magnesium plus 2 hydrochloric acid gives rise to 2 MgCl2 and H2 gas. That is also a single displacement reaction. Is that balanced? That is balanced. You can see 2 Mg, 2 Mg, 2 hydrogen, 2 hydrogen, 2 Cl, 2 Cl. That is not balanced also. So here you can see it is a single displacement reaction and it is not balanced. So here this is again wrong and single displacement. Then the fourth one, 2H2O2 gives rise to 2H2O plus O2. That is a chemical decomposition reaction, and see whether it is balanced. 2 into 2, there are 4 hydrogens, 2 into 2, 4 hydrogens, 2 into 2, 4 oxygen atoms, 2 plus 2, 4 oxygen atoms. So that is a balanced chemical equation and also it is a decomposition reaction. That is the answer. I am sure you were also able to write the correct answer. With that, I will move on to the next question, students. Extra question 24. You can see they have given the equation on top. Fe2O3 plus 3 carbon monoxide CO gives rise to 2Fe plus 3 CO2, that is carbon dioxide. So this is a reaction taking place in the blast furnace where hematite is reduced to iron by carbon monoxide, evolving carbon dioxide gas. Amount of carbon dioxide liberated when 1 mole of Fe2O3 is reacted in the above reaction. So when we say 1 mole of Fe2O3, here students, you will be given the relative atomic masses. If not also, you will have to remember the relative atomic masses to a certain extent. So then, if you can remember, it is there in the textbook. Iron 56, oxygen 16 and carbon 12. So, if we calculate for Fe2O3, here we need to find amount of carbon dioxide liberated when 1 mole of Fe2O3 is reacted in the above reaction. So, if this is 1 mole, that is this is 1, there the carbon dioxide has to be 3 moles. So, if we calculate for carbon dioxide will be carbon 12 plus 2 times 16, that will be equal to 44. So, like that we need to have 3 moles. So, 3 into 44, that will be equal to 132. So, 3 moles of carbon dioxide will be equal to 132 grams. So, then if we look at the question, amount of carbon dioxide liberated when 1 mole of Fe2O3 is reacted in the above reaction, it should be 132 grams. I am sure you all can understand this, students. Now, here you need to look at the balanced equation, 1 Fe2O3, 3 carbon dioxide. So, 1 mole of Fe2O3, if it completely gets reacted or reduced, you will get 3 moles of carbon dioxide. You need to calculate the relative molecular mass of carbon dioxide, 44. Like that, there are 3 moles. So, 3 into 44, 132 grams. So, that is the answer. Then question number 25. Metal that reacts with cold water. So, metal that reacts with cold water. You can remember the metals at the top. Potassium, sodium, calcium, magnesium. Now, potassium is highly reactive. Sodium is also reactive. When we put sodium into water, you all know it is a violent reaction. You saw that in the lab also. It floats around, it darts around the surface of water vigorously. You can hear the hissing sound because hydrogen is evolved, and also you see the quick reaction. And we use a large trough of water so that it does not lead to any explosion. There is a lot of heat evolved as well. So, you can remember the observations. So, metal that reacts with cold water. But when we try to react magnesium with water, cold water, it did not react. It reacts with hot water. So, look at the metals. Zinc reacts with steam. It reacts with steam. Iron reacts with steam. Magnesium reacts with hot water and steam. Only sodium reacts with cold water. So you should remember that, students. Now, and also here you should remember when zinc reacts with steam, it forms zinc oxide, ZnO, and evolves H2 gas. But when iron reacts with steam, you can remember, students, it forms Fe3O4 and evolves hydrogen gas. So you should be able to recall all the reactions. If I write them down, zinc plus H2O, that is steam, you get zinc oxide plus H2. Whereas iron plus H2O, that is also steam, you get Fe3O4 plus H2. So here we need to balance the reaction. So we need to have 4 here, 4 here, and 3 there. Then magnesium, of course, reacts with hot water. Mg plus hot water, you get magnesium hydroxide and H2, and magnesium with steam, you get magnesium oxide and H2, whereas sodium reacts with cold water, giving rise to NaOH and H2. So these are reactions that we have already discussed. I am sure you can remember them. You have to remember the different, students. Whether they react with cool water, hot water, steam, and when they react with steam also, how they react differently. Is that clear to you? So the answer is what we selected. Here you can see metal that reacts with cold water is sodium. So with that, students, I have come to the end of this chapter, but I have some more extra questions under extra question 1, that is the multiple choice questions. So I will continue those in the next chapter.